exponential functions are, or even exponential equations, are when we have, we'll write it as an equation first, something along the lines of y equals a to the x power, or in function notation f of x equals a to the x power, where x is obviously a variable, but a is a real number. A is a real number. So the difference is, instead of x being down here as the base, x is in the exponent, and the a is a real number. Now, a couple things that we have to make sure for something to be an exponential function. We would have to make sure that a is greater than 0. We can't have negatives, because if we think about it, let's say I've got, this is why a needs to be greater than 0. Let's say I have negative 1 to the x power. So if it was, or even negative 2 to the x power, for all the x's I plug in, the signs are going to alternate back and forth and back and forth. So it's not going to have a nice pattern to it. The other thing that we need to make sure is that a is not 1. If a was 1, 1 to any power, it's always going to be 1. So we would end up with just y equals 1, and then it's a horizontal line, and it doesn't have the same patterns as exponential functions do. So this needs to be true for it to be an exponential function. So let's jump into an example. Let's do y, or f of x, either way, equals 3 to the x power. So to get an idea what this looks like, let's just plug in some numbers and see what happens. Let's do negative 2, negative 1, 0, 1, and 2. It's usually good ones just to get an idea when we first try to understand what some sort of equation or some sort of function looks like. So when I plug in negative 2, so I'm going to have 3 to the negative 2 power. So 3 to the negative 2, that is 1 over 3 squared. To make that a positive, remember that if it's a negative exponent and we bring it down to the denominator, it's now a positive. So this is going to be 1/9. 3 to the negative 1 power, this is 1 over 3 to the positive 1, so a third. 3 to the 0 power, anything to the 0 power is 1. 3 to the 1 power is 3. 3 squared is 9. I'm going to throw in 3 as well. 3 to the third power is 27. 3 times 3 times 3, 27. So just to kind of show that this is going to shoot up really quick, the function value or the y value is going to get really large really quick. So let's plot these. So negative 2 is a 9th. Negative 1 is a third. 0 is 1. 1, 3, 2, 9. Now I'm kind of off my graph. The 327, that's me off the board. So, but we can kind of just see, imagine it's going to increase really rapidly then. And going in the negative, towards negative infinity, it's going to just keep getting closer and closer to 0, but never cross the x-axis. So it's just going to get smaller and smaller, as you can imagine, because this number in the denominator is going to get bigger and bigger. So 1 divided by a bigger number means that value is going to be smaller. So this is what generally exponential functions always look like for the most part. The basic one, we're going through 0, 1. It's increasing really slowly until we hit that 0, 1, then it's going to start increasing really rapidly. For most. So that's this one. Let's do another one, and I'll kind of define things a bit more. How about y equals 1/3 to the x power? Or I could have said f of x, either way. So to the 1/3 to the x power. So with this one, let's do the same thing. Let's do negative 2, negative 1, 0, 1, 2. So 1/3 to the negative 2 power. 1/3 to the negative 2 power. Well, really, so this is like, well, 1 to any power is 1. I'm just going to apply the negative 2 down below. So if I have a negative exponent in the denominator, if I bring it back up, now it's a positive 2. So this is going to be 9. You can kind of imagine 1/3 to the negative 1 power. It's kind of like we're just flipping upside down. This is going to be 3 over 1 to the 1 power, 3. Anything to the 0 power is 1. 1/3 to the 1 power is 1/3. 1/3 squared, that should be 1/9. So we can see it's like all the y values are reversed. So now instead of at positive 2, y is 9. Now at x is negative 2, y is 9. Somewhere up here. Negative 1/3, 0, 1, 1/3, 2/9. So it looks very similar, except that it's reflected across the y-axis. So in this case, it decreases really quickly. Once I hit that point, 0, 1, it's going to keep decreasing, but very gradually, getting closer and closer to y value of 0 as x goes to infinity. So that is going to be the case whenever this is a fraction between 0 and 1. So it's going to have a kind of like a reversed pattern, which kind of, if we think about it, it's 1/3 to the x power, so it's the reciprocal always. You know, just like with these values we saw, it's the reciprocal, so it's going to have a different effect on it. So let's kind of define exponential functions a little from what we just saw with those examples. So it's kind of just a couple exponential functions. Again, a couple kind of little bullet points. Notice, I'm just going to kind of sketch, you know, it looks like this or like this. So notice the, and this is always for a general, y equals a to the x power, no shifting right, left, up and down, flipped around, nothing like that, just a basic one for whatever a it is. We would always have a y-intercept of 0, 1. The domain would always be left to right, negative infinity to infinity. The range would always be no points, bottom to top, no points until I hit 0, but then until infinity I have values. So 0. And notice I use a parenthesis because it's never going to actually get to 0, it's just going to get really close. What else? It is a function, it's a one-to-one function. To kind of talk about the difference of these, if a is greater than 1, then the function is increasing. Increasing function. And if a is between 0 and 1, then it's a decreasing function. So like this top one, this is when a is greater than 1. This one is when a is between 0 and 1. It's going to be decreasing. And then the last thing to mention real quick is if you have, the one example we had done is 3 to the x power. So let's say that is my purple line. Now if I do, let's say 2 to the x power. So this case is, let's think about it, is it going to be steeper or more gradual? It's going to be a little more gradual. It's not going to jump up quite as quick. And then it's going to not decrease quite as quick. Well, not really decrease, but approach 0 quite as quick as x goes to negative infinity. And then if we have a really large a, let's say, let's just pick something really big like 12 to the x power, then that's going to increase really quickly. Because if you think about it, at x is 1, the y value is going to be a lot bigger. At 2, it's going to be, in this case, it'll be all the way up at 144 versus 9 or 4. So, and then it's going to get close to that x-axis really quickly, going towards negative infinity.